Hello. In this video we're going to be talking about how to simplify a root expression, or a radical, as the ominous they, sometimes call it. Okay, but here's the basic dilemma, right? And that is, it's difficult to simplify a radical when you have a sum or a subtraction going on with the terms. Okay? Here's the master rule that we're going to be using. Okay? And that is this. If I have some sort of radical where I have terms being multiplied by each other, so let's just say a times b, that can be rewritten as this. That can be rewritten as the square root of a times the square root of b. However, if I have something like this, if I have a minus b, that does not equal square root of a minus the square root of b. You can test numbers on this to see that this makes sense, but this is a very important distinction that we have to make. If we have multiplication or division, we can break up the inside of the radical into these different parts, and those are usually easier to solve, but not if it's sums or differences. We cannot do this. So, what that's going to indicate here is, right off the bat, a mistake would be to think that we could write this as cube root, G6H3 and minus the cube root of 27G4H3. We cannot do that. Okay? That is not allowed. But what we can do is we can try to rearrange this inside here in such a way that we can rewrite it as a multiplication problem. In other words, like here, let me give you an example of that. Supposing I had something like this. I can say, let's say I had 4x minus 12 was a number that I have. Well, these two terms are it's a difference between these terms, right? Subtracting them. But I could factor out the greatest common factor, which in this case would be 4, and I could rewrite that as x minus 3. Now, what I just did right there was I turned this into a multiplication problem. I now have two separate terms. See what I'm getting at? So now it's 4 times x minus 3. So if this was a radical, if I had something like this, here, let me clear up a little bit of space, I could rewrite this as such. I could say that's the same thing as the radical, oops, 1 second, there we go. That's the same thing as this, which would be 4 times x minus 3. And again, positivity if need be, to make sure that you follow what I did here, that these two things are equivalent. All I did was I just factored out a 4. If I distribute it back in, we get right back to where we started from. But now I have this as 4 times this whole thing, so I can rewrite this as the product of two separate radicals. Now, I can't really simplify this one because I don't know what x is, right? But I can simplify root 4, that's just 2. So really this whole thing boils down to, if I started with this, 4x minus 12, the root of that, I can simplify that to that's the same thing as 2 times root x minus 3. We're going to do the exact same thing for this problem right here. Complicated just a slight bit by the fact that we have, so actually let me leave that up here for a second. Let me cut this. Complicated a little bit by the fact that we have it's a third root, right? So here, this is what we're going to do. Your knee-jerk reaction, I might do another video at some point getting into more detail about that, but for now, just trust me on this. Actually, that's a terrible, never trust anybody, okay? If somebody says trust me, they're lying to you. Life lessons, all right? But here's the idea. Since we're taking a cube root, we want to try to factor stuff in multiples of 3, right? So if we could factor out a 3 for a variable, or a 6, or a 12, or anything that can be divisible easily by 3, that's what we're looking for. So like, for example, look at this. This g over here is a g4, which is not going to match up with this 3. So what I'm going to try to do is I'm going to factor out, I want to convert this into something like this, right? Some term times another term so that we can break it up. But here, let's see. And again, I want to kind of factor it in terms of 3. Well, let's see. What terms do we have in common? Let's start there for a moment. I think I'm babbling a bit. Well, we have a g and an h in this term, and we have 27, a g, and an h in this term. So it looks like what we have in common here is g and h. Now, excuse me, if we factor out the biggest g value that we could, that would be g4, right? That would be g to the fourth, and the biggest h value that they have in common is h third. Okay, and that would leave us with, let's see, what would happen here? If we factored out g4 from the left-hand side, that gets us to g2, right? Because remember, if the same base, if you're factoring out with exponents, you just add the exponents back in to get where you started from. Well, h third, if I factor that out, that's just going to be, well, 1 in there. So I'm just going to put that for a second. Minus 27, and then the g is gone, right? Because we factored out the 4. And the h is also gone, so that gets us to this. Well, and that's totally fine. Technically didn't really need to write that times 1 there, but I hopefully get the idea. Let's cut that out. Okay, well that's fine. We could do that. But remember, we're interested in order to factor, we need groups of 3. So that's fine for the h, right? That's in a 3. It's going to match up with this. But the 4 isn't going to be super helpful. So let me just remodel that a little bit. Instead of factoring out 4 g's, I'm just going to factor out 3 of them. So here's what I'm going to write instead. I'm going to write g3 times h3 times all of this. But remember, we just factored out 3 g's, so now we're going to have g3 there, right? And again, just double check me. g3 minus 27g. Okay? Again, if you take this and distribute the g3 and the h3 terms back in the parentheses, we end up exactly where we started from. All right. But now that means, okay, look, I wrote this as the product of 3 different terms, right? There's this thing times that thing times this thing. So I can write those all as separate using this rule right here. I can write these all as separate radicals. So that's root 3 g3 times root 3 h3 times root 3 whatever this is, g3 minus 27g. g3 minus 27g. Okay, well, I think we kind of see where we're going from here. I can simplify the first 2 terms, right? What is, if it's g, take the root 3 of g3, well, that's just going to be g, right? It's basically asking, okay, what 3 numbers do I need to multiply together to make g to the 3rd power? Well, that's just g, because g times g times g makes g to the 3rd. So there it is. Same logic. That's also just going to be h. And then, okay, we can't do anything here. Remember, we're not allowed to do this. We can't just take, if we're subtracting 2 terms, we can't just split those up and find the roots of those. So we just have to leave that be. We have to leave that go. So that's just going to be this. g3 minus 27g, and that was to the 3rd root. And again, I know this can be confusing to people because you're looking at, well, I got g3 here, and I'm supposed to find the 3rd root, so wouldn't that just be g? No, it would not. Because you don't just have g3, you have g3 minus 27g, and you can't factor out g to the 3rd from both of those terms. So you just have to leave it go, and that would be our answer. G times h times the cube root of g third minus 27g. So it looks like that is answer choice B. Where's my pen? There it is. All right, this went a little long. We'll stop here, but review over this as this is confusing to you. But these rules here are very, very important. These are common traps when you're trying to simplify exponents. Remember, you have to try to factor, and then once you have stuff factored and you're multiplying these things together, you can split up those terms into individual radicals and simplify. Hopefully this was helpful.